Welcome to Engineering Scale Models. I'm Jason, your host, and I do models. How is everyone doing today? And just to start off, no, this isn't a logic video. This is a getting set up for electronics video. I'm doing some more basic electronic stuff to get you guys locked into putting them LEDs in your tanks and your ships and your aircraft carriers and your just all kinds of cool basic LED action for your, or some moving parts, whatever you need to do. And this is my test breadboard. This is the one I use for videos, and I build my test circuits on here. But one thing that's common between the breadboard that I always have on a test breadboard is this section up here is my power and like control section. It has a plug-in power supply, and then I use one of these jacks so I can just plug in my banana plugs in here. This gives me 3.3 volts or 5 volts. But I have to put in 9 volts though. But I use a power supply for that, or you can use a 9-volt battery and stick it right here and power it that way. Then I have a 555 timer in astable mode. I have a 555 timer in monostable mode. And then a recent addition that I added to my my thing here is in 74LS161. It is a binary 4-bit asynchronous counter. And it's hard to explain why that would be important, but for some projects that I need to test, I just happen to need that. And I'll show you what this stuff looks like right now. Let me turn on the power supply. My singlet SPD3303X-E from Singlet. Visit Patreon to help me afford this equipment. So I have channel 1 set up. I don't have the software on here for this yet, but I will. And I'm going to turn on channel 1, and we're going to push the button there. So disregard this down here. That's a different project. Pretty cool project, but different. So as you see here, this is the astable mode. It blinks the LED, and then I can control with this potentiometer. It's slower now, really slow, and then I can speed it up. So it makes a good pulse circuit for like testing some logic gates, or just a random way to pulse and blink some LEDs and things. So if you want to test something and you need a pulse, that 555 timer's right there. It's nice to have that pulse instead of setting up the wave generator or things like that. Next, I have this push button here. It just basically lights this LED one time, and it's basically the same as this clock. It sends out a clock pulse through the 555. So if I need one clock pulse, I have one clock pulse. And then if right now this switch, this counter is counting on this clock circuit here, this 555 in astable. If I flip this switch, the clock will stop, and then I can increment it with the other 555 timer. So if I want it to be at 0, and then say I wanted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I got 15. So I got a little 16 counter from 0 to 15, or 4 bits. And you'll see that come into use in other videos. But the reason I'm explaining this to you is because I want to show you guys this here. Let's turn this off. And I want to show you what I got here. So I like uniformity, and I like things to all work together and be the same. It's like meters. I buy my meters in 2s. I have 2 of these. I have 2 of these. And I have 2 of these. Just, it makes life easier to have 2 of the same meter. 1 meter's nice. A meter's nice, but when you're getting into trying to troubleshoot circuits and you want to check current, but then you also need to probe for voltages, having 2 meters is handy, but having 2 meters of the same brand and quality, it just, those two are going to act the same way, because all meters have their little quirks, unless you spend like $500-$600 on a meter. It may not have any quirks, but I bet it has something. And then I have one desktop meter, but benchtop meter, and I do plan on getting another one in the near future, I hope. It's my goal anyways. So, back to the topic of today. I got another one of the breadboards. So, this was a kit on Amazon. It is I believe it's around $30, but it's one of the better ones out there. There's this one in Matronics, and it is only a couple dollars more to get the little box of breadboard connectors. It's not a whole lot of breadboard connectors, but the box is well organized, and it is a box of breadboard connectors. So I got the combo on that. So I got another board and more of the breadboard connectors, which I will just generally mix with my other connectors. So it comes with this little bag of goodies here. We got some little feet. So we'll flip this over. We're going to set this board up today. I'm going to show you how I set it up for building circuits, for building prototype circuits. The only downside to this board here is now that it has the feet on it, it's got a little flex in it, so when you push down on your chips, it wants to flex a little. But I have some more feet in a drawer. I'm gonna put a foot in the middle to prevent that from flexing. So, because it's just like really bad in the middle. So let's put on our connectors. We're going to do them the same way as the other one. And it is keyed, so you have to be aware of that. Both ends are keyed. Is that one? This is just going to be a long video. I don't really have any topics other than this video. I just, a lot of people want to get started in electronics, and they watch some YouTube videos, and then they buy, $100 worth of test equipment, maybe more, and then they try to use their stuff, and then they don't understand how it works. And it's mostly because you didn't understand the basics of basic electronics. Like if you watch someone hook an LED up to a resistor, you know what value resistor to use and what kind of LED to use and how to hook it up, but you don't know why it works that way. So it doesn't give you the broad, like, fundamentals of why it's hooked up that way. Like, take capacitors for example. You know, I'm going to be using some capacitors in my 555 timer, and if you want to, you know, I watch videos on YouTube. I watch a lot of technical channels, and I see tons of videos of people setting up 555 timers, and there's very few out there that explain why they pick the value of capacitor that they pick. And that's like a point of teaching somebody fundamental electronics, is to teach them why they're... Oh, this one's all wonky. Okay. But to teach them the fundamentals of how it works, because that way you can go in there and you can change a value of something, and you know, you're gonna feel confident that you know what you're doing. And well, I don't have a pair of pliers that I can tighten those up with, I don't think. Let's try these. These are definitely not made for this, so we're just going to tighten them with this. So now these are all screwed down. I'm going to loosen up these red ones and black one, and I'm going to get me out a Okay, so this is a 5mm 2.5. It plugs into one of these little generic power supplies. You can get them, you know, $5 or $6 on, you know, like 4 or 5 of them for $5 or $6 on Amazon or eBay. You know, that's your call, however you want to get it. But I want to plug that in there. I like to make sure that it is in the last hole. It is. And then I'll plug my banana jack in, make sure there's no issues. And then I will come up here and thread these through the holes. Screw that down. Alright, so if I hook up my 9 volts to this, it should power this LED, and I should have voltage on that rail, and we're going to check that just to make sure. Let me turn the power supply on. Okay, I have power there. Let's check the rail. I have to get the right ends to my meter. These meter probes, I don't know the name brand of them, but you know, if you're working with low level electronics, not a lot of high amperage and current, because I don't know what the rating of these are, but you know, they have the same end on there, but you can take this off and you can put on different things like alligator clips, and also you can change the tips so they're more accurate. The only meter leads I use, I won't use any other meter lead. So we're going to use this meter here because it shows up good on camera, otherwise I wouldn't use it. So we're going to go to voltage, and it's going to auto us in DC voltage, and we're going to check our rail here. So it should be 5 volts all the way around. So if I probe here and here, I get 4.9 volts. So 4.9 and 5 volts. Now I don't have voltage anywhere else yet because I haven't connected anything on the board yet, but I will. Let's put this meter up here like so. This is just going to be a free-flowing video, so if you guys don't want to watch it, it's okay. I can hold it against you. Alright, so we have that. Now let us grab our components and see how we can put them on this board here. Okay, I'm going to need a switch. Grab the switch here. Switch. Need some 555s. That's a 555, and here is another 555. Okay, so I need some LEDs. I'm gonna go with this white one. There's a nice light blue. And then I'll think about the 4 counter lights while I think about that. So now we'll put the counter on last. So let us get this chip on here. So if you look at the chip, pin 1 is right there. Pin 1 is right here, but the chip faces this way. That's how you know that this is pin 1. So now I know my power and ground are the first pin and the 8th pin, so I'm going to make sure that I'm in a row where I can tie into that pretty easily. So there we go. That's in there. So that's in there, and then I'm going to have the output about here. So I'm going to I want the output to be out of the way this time, so my ground is the short lead, So what I'm going to do is I'm going to bend my power lead here. I'm going to bend that like that. And I want to check it. This is going to plug in there. It's got to go to negative. So I'm going to come over to about right. What I'm going to do. I'm going to take a piece of red heat shrink, or red wire insulator, because this is my positive. Or the anode. I'm going to securely press that on, and then I'm going to bend that down like that. Now I know that that side is the positive. And these are just, I stripped my own wire for the breadboard, so they're just the wire sleeves, and they tend to fit perfectly. So I'm going to crop this down a little bit. So that will fit nicely in the breadboard, just like so. Okay, that's that one. So now we need one for the push button. So we'll do the same thing. We'll bend out the long leg. Then we'll put because it bent the positive leg, it gets a red one. If I bend the negative leg, it gets a black one. So and this also helps if something bumps into it or whatnot. I know the breadboard is a temporary situation, but what I build up here is more permanent, so this just gives you a look into, I don't know, my brain, how crazy I am with my weirdness. There we go. So that's going to be for the buttons. Now we need some power wires, and I will show you how I make the power wires. So I will not use my breadboard. I will grab my gray wire marker here, if I can pick it up. Grab, this is the length of wire I use for my power, and I'll grab my little box of wires here, and I will start cutting some of these power and ground black wires. That's for one chip. This will be for the next chip. So each chip has a power and a ground. And I chop these to this specific length because my stripper is a Calpix and it strips the insulation. And this is about the shortest wire it will strip. And I'll just strip these. And I'll show you the fancy way I bend them to get them to fit in the breadboard. So that one got stuck in there. Alright, so I saved these little sleeves because I use them on to cover up components. So now I will take this And I will take my, this is like a round bending for like wire and stuff for like jewelry. So I take that and I will put it in there, line it up, squeeze it, and bend up like that. And now it's a perfect fit for my breadboard. Well, that's not the right pen. For my breadboard, and also it has a little hump to it, so you can you can hook a pair of pliers under there. You could use the pliers to put it in, and it makes a nice little hump there. So let's bend this one here. Especially with these little, these smaller wires, they can be a pain to put in and get out, but this seems to work pretty well when I do this technique to them. I don't do it to every wire, but some. And this is a box of 22 gauge Crosby silicone wire kit. It's hookup wire kit. Choose your desired design. They make a silicone and a PVC. This is the silicone. Well, actually, it doesn't say silicone or PVC. It's just something was supposed to be marked and it wasn't. But when I ordered it, it came in and I wrote 22 gauge. So it is the silicone because it's got that nice silicone-y finish. It's a little bit more expensive than the PVC, but I like it. It works. It gives a nice feel to the wires. I'm actually running low on black and red, I believe. Yeah, red and black I'm running a little low on. And it's nice, they come in these little containers, so if you want to take them out of the box, you can do that. But it's very nice. Very nice. I believe it's a little bit more money, but I believe it's worth it. So we got our wires, and our wires for our second chip here. Okay, so let's put our second chip. Now, I did not get the resistor out for the LED. So it's a 220 ohm resistor, and I want to go from pin 3. No, that's too far. Pin 3 right there, that seems better. I like to make my breadboard as neat as possible. And the one thing, okay, that's not what I planned on. Sometimes they just don't want to go in, especially when you reuse these resistors. Let's check our white LED. There we go. That looks like a nice tight circuit. It's not going to be in the way of me trying to connect anything else. So let's get our potentiometer out here. I need a okay, so that one works. So I need a 205. That's a 201. 205 is 2 megohms. 2 0 and 5 zeros. That's a 204. That's a 501. What's a 104? I'm sorry. 103. And a 504. Alright, let me grab my potentiometer box. Two, 201, it's 204, 201, 202, 203. Yeah, this is the insanity. 501. 202, 104, 104, 103, 503, 203, 102, 101. 201. Wow, I know there's mega resistors in here, or potentiometers. 204. 103. 102. 504, 203. Do I not have these up in megohms? Why would I buy these if they didn't have megohms? The only thing I bought these for was trim circuits for like these timers. I haven't seen anything in 05 yet. Well, there's a 1 meg of the other style, but I'm not a fan of that style. I'm sure this is captivating me dig through a dish of potentiometers that desperately need to be organized. And I found it 205. Okay. So apparently I don't have 1 megohm in these, which is sad because I wish I did. Probably do it with 500K, but I don't know. I like to have at least 2 meg. It gives me more of a range. Alright, and then I need a 1K resistor, and a 1K resistor is 10K. A 1K resistor, I can't talk. 1K resistor is going to be brown, black, red if it's a 3-band. These 5-color, 4-color things are just so irritating. I'm just going to measure this in ohms on this meter. It is early in the morning. I got a pile of resistors here, and I think this is oh yeah, apparently that's a 1 meg resistor. Oh no. 2000K. Well, that's a horrible thing. It doesn't even tell you. It doesn't even tell you the... Wow, hold on. That is... Yeah, that's a down for that meter. Let me grab this meter here, because it didn't tell me. It just said 940. It didn't have a K by it or anything, and I am not in the mood for that. So okay, so that's a 1 meg ohm resistor. How 1 0 and 2 zeros 10 times 100 is it doesn't make any sense why that's 1 meg ohm. Alright, I'm not in the mood for this right now. Brown, black, orange is 10K. I'm just going to test these. My brain is not working. Yeah, that's 10K. So what's down 1 from orange? So red, so brown, black, brown, red. I don't have any of those in here. Brown, black, red. Found one. Let's just check this right here. The light went out. Alright, let's just check this resistor here. Shows up on the camera. Yeah, 1K. Okay, we found a 1K resistor. Wow, that's how you do it if your brain doesn't work. So there you go. Brain wasn't working. So I'm going to turn the meter off so it doesn't beep later. Turn on this light. Plug this one in. Well, I'm using one of these Lume Cubes, and it got so hot that it heated up the whole base. Tripped its thermal fuse, I think. Okay, so this has got to go from pin 6. So So from pin 7, pin 7 to 5 volts. This is what's going to be with the potentiometer. I'm going to insert like so. Like so. And then I need this guy in there. See, the problem with me and resistors is all the, kits I buy, like bulk electronics parts, because you can get bulk electronic parts for pretty cheap. And all the bulk electronic parts I get come with those metal film resistors, and I don't like that 5-band code. I'm not a fan of that 5-band code. I like a 4-band code. That's what I grew up with. I know the tolerance is a little, up in the wind on that, but so I have a 1K resistor from pin 7 to 5 volts. Then I have my 2 meg a 205 or a 502. I'm gonna have to measure that. I can't tell. Look at that. See, I think that's a 502. Yeah, it's a 502. So we're gonna use the 105. Gets confusing. Okay, so here's our potentiometer in there. I talked about potentiometers in another video. Or that helps. Washed it out a little bit. Turn that down. I didn't even realize that light wasn't on. So, what's next here? We need to connect pin 6 to pin 2. So I am going to go in a little jumper box here, and I'm going to pull out one of my pre-bent yellow ones. And I'm going to see if that will jump over the chip here. So pin, I'm going to flip this around. Doesn't matter, I can do that. It's just going to be turn the opposite way to slow it down. So pin 6 and pin 2. Sorry about that, guys. Okay, so that one is not appropriate. It's got too much of the... So, let me have... So I'll take my next size measuring guide. I'll cut a yellow one. I have a little guide wire for every length I need for the breadboard. It's not a perfect system. After this video, I'm going to make some official links with polystyrene. Now I'm just going to bend this a little bit just to give it some contour. Because after I give it a little bit of a hump, I'm going to come in I'm going to bend that pin down like that, and that pin down like that. And now that should seat down where I need it to. I say that. Okay, there we go. So that's that. So let's put our potentiometer back in here. Now the only thing we have left is the capacitor. And the capacitor is a 1 microfarad. So I have some electrolytic capacitors. Actually, I am going to use, see, this is what's good about learning. You can get boxes of components, and then you can try new things. So let me see if I have a 1. Now these all look like, these polyester film canisters look like all nanofarads. I haven't got to use these yet. I got to use these. I got these in bulk. Yeah, these are all nanofarad. How many times is this taped together? So let's see, we have 0.2, 470 nanofarad. So that'd be 0.47, I believe, microfarad. Quite big capacitors. Doesn't say what the voltage on these are. Or the value. 2A474. Look, it's a capacitor. It doesn't even tell you the value or the voltage. Oh. I'm going to highly not recommend this kit. Highly not recommend that. So then we have a choice of our ceramic capacitors. Here we go. These are our ceramic, and we could do 1 microfarad here. We could use this type of capacitor right here. So we use one of these. Let me make sure it's a 105. Is that right? That seems right. So I got this. I need to make a cheat sheet for these capacitors, or I can use a electrolytic capacitor, and I'm going to show you the difference here. So these are nice. These just have them written on the side of it, but my container got mixed up, so there's more than one. So now you want to be careful when dealing with capacitors. You want to make sure you don't charge them up and touch the leads. Now, this capacitor needs to go to ground. So this one is polarized, so it has a ground side on it, and the other side is positive. The short leg is ground. And then the ceramic capacitor doesn't matter. So we could take this ceramic capacitor and we could put it between 2 and pin 1, and that would effectively get us to ground. I don't like the stress that puts on that circuit. So effectively that should work right there. So let us test this out. I normally tie pin 5 down. I have to look at this because it's with a 100. So I tie down pin 5 with a 100. So 100 is this one, I believe. That's a 104. Just check that real quick. I'm going to check this on the capacitor and see what this runs up at. So if you want to check capacitance, you just put it on capacitance and you press select to make it, wow, it's a loud beep. There's capacitance. Let's check out what this is. So that's 14 nanofarad. Or it's probably 10 nanofarad. This is 10 nanofarad. This is a 10 nanofarad read. These numbers are just arbitrary. Nanofarads. So that's a 10 nanofarad one, right? Yeah. So use a 104. Decoupling capacitor. 100 nanofarad. Okay. Man, I am having difficulties reading components. So I'm going to put that across pin pin 5 to ground, I believe. Yeah, that's to ground, so I need to bend these leads out here. I'm going to bend them close to this capacitor. Probably shouldn't do that. Definitely shouldn't do that. And this is just a decoupling capacitor to take out some of the noise. So, pin 5. Alright, now in theory they should fire up. So, turn it on. And okay, something's not working. Power supply's on. Let's check our voltage here. Let's check our voltages everywhere just to make sure we're getting voltages. So, AC voltage, I'll bring the meter up here. Chip's not getting hot, so let's first check the voltage on the chip here. chip voltage is, there is 0 volts on that chip. Why is there 0 volts on the chip when there is 0 volts on the rail? Oh, wow, guys, y'all didn't call that? Wow. Wow. This is not my day. It works if I hook up the power. Wow, this is turning to a comedy of errors. First, for some reason, my brain can't read components. That's probably the brain damage. And then I didn't hook up the power, so that's hilarious. So I can make it go faster. So it's, oh man, of course I picked the one LED that's hard to see. I'm going to swap it for this one. There you go. How's that? Oh god, you can't see that either. Alright, let me turn this off. Let me turn this off. And let me do this. There you go. Now you can see it blinking. And now we're going to make it blink faster. So we can have a super fast clock cycle. And then now I can't even focus because of the light. Okay, so there is the 555 section of the circuit board. And that has been an hour. So I am going to call it. And I'm going to pick up the second half of this in the next video, putting the second 555 on there, and this time I'm going to have everything ready. I'm not going to, well, I'm going to do it live because that's fun. Alright guys, thanks for watching. Social media, Patreon, maybe I can afford an education in reading capacitors or resistors. That would be useful. Thank you guys for watching, and have a fantastic day.